Hello and welcome back to this channel once again. In today's video, we are going to focus on components of a vector. We are going to consider a vector in a three-dimensional space. So let's assume that we have 3 points in a three-dimensional space. We have point A with coordinates 1, 0, 0, point B 0, 1, 0, and then point C 0, 0, 1. Now remember that the first value is the x value, the second is the y value, and the last one is the z value. Now considering this to be the Cartesian plane, we have this to be the x-axis, the y-axis, and also the z-axis, and then we have O to be the origin. Now point A is going to lie on the x-axis simply because it has a non-zero x value. So on the x-axis we mark 1, on the y-axis we have 0, and also on the z-axis we have 0. Therefore this is point A, 1, 0, 0. We also have point B lying on the y-axis, and that is 0, 1, 0. And we also have point C lying on the z-axis, so that is 0, 0, 1. And the vectors OA, OB, and then OC lie on the x-axis, y-axis, and the z-axis respectively. Now what do you think will be the magnitudes of the vectors OA, OB, and then OC? Now the magnitude of the vector OA is simply given by the square root of the square of the x component plus the square of the y component plus the square of the z component. Now we have the x component to be 1, the y component to be 0, and also the z component to be 0. Therefore we are going to substitute these values here so that we have 1 square plus 0 square plus 0 square. Now 1 square plus 0 square plus 0 square is equal to 1. So we have the square root of 1, and the square root of 1 is equal to 1. Therefore, the magnitude of the vector OA is equal to 1. In the same way, we have the magnitude of vector OB also to be equal to 1, and the magnitude of vector OC also to be equal to 1. And these vectors are said to be the unit vectors along the x-axis, the y-axis, and the z-axis respectively, and they are denoted by I cap, J cap, and then K cap. So I cap is the unit vector along the x-axis, J cap is the unit vector along the y-axis, and then K cap is the unit vector along the z-axis. Also, let's assume that we have a point P in a three-dimensional space. So we have this to be the Cartesian plane. This is the x-axis, we have the y-axis, and also the z-axis, and we have O to be the origin. Now let's assume that this is point P, and P has coordinates x, y, z. Now what this primarily means is that in order to move from point O to point P, we need to move some distance along the x-axis, some distance along the y-axis, and also some distance along the z-axis in order to arrive at point P. Therefore, we say that the vector OP is the position vector of P with reference to O. So this is the vector OP. Now, since I cap, J cap, and then K cap are said to be the unit vectors along the x-axis, the y-axis, and the z-axis respectively, then by definition, we have the vector OP to be equal to, now P is the terminal point of the vector OP, and then O is the initial point. Therefore, the vector OP is given by, we have x minus 0 I cap plus y minus 0 j cap plus z minus 0 k cap. Now we can simplify this as vector OP, and that is equal to vector P. This is equal to x I cap plus y j cap plus z k cap, and we call this the component form of the vector OP. Now x, y, and z are said to be the scalar components of the vector. So scalar components of the vector, and then x I cap, y j cap, and z k cap are said to be the vector components along the x-axis, the y-axis, and the z-axis respectively. And the magnitude of the vector OP is given by the square root of the x component square plus the y component square plus the z component square. So if A and B are two vectors expressed in the component form, such that we have vector A to be A1 I cap plus A2 j cap plus A3 k cap, and we also have vector B also to be B1 I cap plus B2 j cap plus B3 k cap. Then the sum of the two vectors A and B is given by vector A plus vector B, and that is equal to, basically we are going to add the corresponding components. So we have A1 plus B1 I cap plus A2 plus B2 j cap plus A3 plus B3 k cap. Now if you want to find the difference between the two vectors, that is given by vector A minus vector B, then this is equal to, we are going to subtract corresponding components. So we have A1 minus B1 I cap plus A2 minus B2 j cap plus A3 minus B3 k cap. Now if the two vectors A and B are said to be equal, then their corresponding components are also equal. Therefore, if vector A is said to be equal to vector B, then it means that A1 is equal to B1, A2 is equal to B2, and then A3 is also equal to B3. Now the multiplication of vector A by a scalar, say lambda, is given by lambda times vector A, and that is equal to, you are going to multiply each component of vector A by lambda. So you have lambda A1 I cap plus lambda A2 j cap plus lambda A3 k cap. So having this in mind, let's try a few examples. So for example 1, find the vector joining the points P, 2, 3, 0, and then Q, -1, -2, -4, directed from P to Q, and hence its magnitude. So from the question, we are given 2 points. We have point P, which is 2, 3, 0, and we have point Q, -1, -2, -4. Now we are asked to find the vector joining these 2 points and hence its magnitude. Now from the question, you realize that the vector is said to be directed from point P to point Q. Therefore, point P is said to be the initial point of the vector, and then point Q is the terminal point of the vector. So the coordinates of point P is going to be x1, y1, z1, and then that of point Q is going to be x2, y2, z2. Now the vector joining the 2 points P and Q is given by vector PQ, and that is equal to, we have x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So let's substitute the corresponding values in here to find the vector PQ. So we have x2 to be -1 minus x1 is 2 plus we have y2 to be -2 and then y1 to be 3 plus we have z2 to be -4 and then z1 to be 0. Now let's simplify this. So -1 minus 2 is -3. So we have -3 I cap. -2 minus 3 is -5. So -5 j cap. And then -4 minus 0 is -4. So we have -4 k cap. Therefore, the vector joining the 2 points P and Q, which is giving us vector PQ, is equal to -3 I cap minus 5 j cap minus 4 k cap. Now let's find the magnitude of this vector. So the magnitude of vector PQ is equal to, we have the square root of the x component square plus the y component square plus the z component square. Now we have the x component to be -3, the y component to be -5, and also the z component to be -4. So let's substitute that in here. So this is going to be the square root of -3 square plus -5 square plus -4 square. So -3 square is 9, -5 square 25, and then -4 square 16. 9 plus 16 is 25. plus 25, we have 50. So that is the square root of 50. And the square root of 50 can be simplified as 5 root 2. Therefore, we have the magnitude of vector pq to be 5 root 2. Now let's move on to the second example. So for example 2, given that vector A is equal to 2i cap minus j cap plus 2k cap, and vector B is equal to negative I cap plus j cap minus k cap, find A, vector A plus vector B, B, vector 2A minus B, and then C, the magnitude of the vector 3A plus 5B. So let's solve these together. So we are given the vector A to be 2i cap minus j cap plus 2k cap. Now we can represent vector A in the scalar component form as we have vector A equals 2, negative 1, 2. Mind you, this is different from a point. Now this is a vector. That is why we have the components in the angle bracket. And also for vector B, we can represent that as negative 1, 1, negative 1. Now let's find the sum of the two vectors A and B. So we have vector A plus vector B. So basically what we are going to do is we are going to sum the corresponding components. So we are going to add 2 and then negative 1 and then 1, and then 2 and negative 1. So that is equal to, we have 2 plus negative 1. So that is for the x value. Also for the y value, we have negative 1 plus 1. And then for the z value, we have 2 plus negative 1. Now let's simplify further. So this becomes, now 2 plus negative 1 is 1. Negative 1 plus 1 is 0. And then 2 plus negative 1 is 1. Therefore, the vector A plus B is equal to, we have I cap. The y component is 0, so we have I cap plus k cap. Now let's solve for B. So for B, we are going to find the vector 2A minus B. Now we have vector A to be 2, negative 1, 2. And then vector B to be negative 1, 1, negative 1. Now let's simplify this. Now because we have 2, which is a scalar, we are going to multiply each component of vector A by 2. So that's going to be 2 times 2 is 4. 2 times negative 1 is negative 2. 2 times 2 is 4. So we have this minus negative 1, 1, negative 1. So let's subtract corresponding components. So we have 4 minus negative 1. And then negative 2 minus 1. 4 minus negative 1. So this becomes, now 4 minus negative 1 is 5. So we have 5. Negative 2 minus negative 1, that is negative 3. and then 4 minus negative 1 is 5. Therefore, the vector 2a minus b is equal to 5i cap minus 3j cap plus 5k cap. Now let's solve for c. Now for c, we are going to find the magnitude of the vector 3a plus 5b. So for c, first of all, we need to find the vector 3a plus 5b. So basically we have 3 times the vector a, we have 2, negative 1, 2, plus 5 times the vector negative 1, 1, negative 1. Now let's multiply 3 and then 5 across respectively. Now 3 times 2 is 6. 3 times negative 1 is negative 3. 3 times 2 is 6. We have this plus 5 times negative 1. We have negative 5. 5 times 1 is 5. And then 5 times negative 1 is negative 5. Now 6 plus negative 5 is 1. Negative 3 plus 5 is 2. And then 6 plus negative 5 is 1. Therefore, the vector 3a plus 5b is equal to I cap plus 2j cap plus k cap. Now let's find the magnitude of this vector. So the magnitude of vector 3a plus 5b is given as, we have magnitude of 3a plus 5b equals, we have the square root of the x component square plus the y component square plus the z component square. Now we have the x component to be 1, the y component to be 2, and then the z component to be 1. Therefore, let's substitute these values in here. So this is equal to the square root of 1 square plus 2 square plus 1 square. 1 squared is 1, 2 squared is 4, so 1 plus 4 is 5, plus 1 squared is 6. So we have the square root of 6. Therefore, the magnitude of the vector 3a plus 5b is equal to the square root of 6 units. So that's it for today's video. Thanks for watching and see you in my next video. Bye bye.